Hi everybody, in this video I describe the content of the course with the title of Design of Passive Photonic Component in Lumerical Tools. So I would like to introduce myself first. I'm Majid and I'm currently working at Ozen Engineering. I hold a PhD in photonics. As a simulation expert in the photonics device, I have extensive experience in this field. So at Ozen Engineering, we are expert in simulation of optics and photonics, structural, thermal, fluid, and electromagnetic fields. We are ANSYS Elite Channel Partner. I will teach you how to design passive component for photonic integrated circuit in this course. The first thing I will do is to discuss different waveguides and fiber using the Lumerical tool. I will teach you how to calculate dispersion, group index, and other parameters in component and circuit level. So using this picture, you can see the workflow of defining waveguide, calculating mode, extracting effective index, and dispersion, and extracting S parameter. Finally, with Lumerical interconnect, a circuit model is created using this compact model. The next step is to design the beam splitter, the wire branch, and the interferometer. We will calculate transmission and reflection, extract S parameter, and use Lumerical interconnect at circuit level. You see here, we start with Lumerical FDTD to calculate the transmission insertion loss. Then in step 2, we calculate the S parameters. And in step 3, we use the compact model that we created in previous section in Lumerical interconnect to calculate the circuit behavior. Then you will learn how to design a Y branch with the maximum broadband transmission using parametric optimization. The workflow of this design is demonstrated in this picture. For optimization, we will use Python. So we start with Lumerical FDTD. So we use a simulation script file. Then we parameterized our structure, as you see here. Then we will use a Python and ANSYS Lumerical FDTD. And finally, you can run the optimization, 3D FDTD, Y branch, and you can export the GDS file and use the GDS file in other softwares. So next, we will teach you how to design an edge coupler. So decoupling of light from fiber to the chip is one of the main challenges in designing photonic chips. You will learn how to design and optimize couplers using Lumerical tools. In this part, you will learn how to calculate mode overlap between fiber and waveguide. You see here, this is a fiber and this is a waveguide. How to optimize a taper, and how to extract the S parameter from the previous section, import them into the Lumerical interconnect, create a circuit, and analyze it at the circuit level based on those parameters. So you see here, we have a fiber, we have a waveguide. So we calculate the mode overlap. So here the taper that we want to use, and then we calculate the S parameter and extract the compact model. Next, you will learn how to design a grating coupler. We will use grating waveguide and single mode fiber. The fiber position, the grating pitch, the duty cycle will be optimized. After that, we will export the S parameter and create a compact model library that we will import it into the Lumerical interconnect. And in the Lumerical interconnect, you can calculate a parameter in a circuit level. The next section, we will discuss other components such as the directional coupler, photonic crystal fiber, photonic crystal, multi-mode interference, waveguide taper, spot size converter, ring resonator based on Monte Carlo simulation, phase shifted Bragg grating, optical filter, and switches. Next, using the component that we have designed in previous section, we will create optical filter and switch. As you see in this picture, we use a directional coupler, we use a waveguide, we use a different instrument like optical network analyzer, and next. So in the next step, we will define a project based on your needs, and I will help you review your project in different areas like LiDAR, photonic integrated circuit, silicon photonics, and other areas. So this course will teach you how to model and analyze photonic chip passive component using Lumerical tools. You will have access to our Lumerical resources, and we can collaborate on potential projects. So you can contact us with these details. It's especially support@ozening.com. So thank you very much and see you.